So thank you guys all for coming this morning. I'm going to kind of read the first part of my presentation, just to kind of make sure that I frame everything correctly and explain it going into the methods, and then I'll go through the methods stuff and do a little bit of wrapping up on conclusions. So. The environment is an indiscriminate actor on human populations that is intertwined with the complex dimensions that construct human experience. The impact of changing and volatile climates on the population is therefore dependent on the specific physical and cultural context within which it is occurring, making climate change a spatially, socially, and culturally relative phenomenon. Recent research on the globalized impacts of a changing climate reveals that climate change is having profound disruptive effects at local levels on ecosystems and subsistence-oriented farming communities. Subsistence-oriented farming communities, or what I'll probably refer to as subsistence-based farming communities, are communities of people who depend on natural resources for their livelihood and who typically rely on long-term intergenerational sharing of cultural knowledge concerning ecological systems, experiences, and environmental processes. These communities have been identified as particularly vulnerable to climate change because they're often limited in their capacity to adapt to climate volatility due to various socioeconomic, demographic, and political constraints. Potential responses to changing climatic regimes in subsistence-based farming communities can be simplified to one of three options. People can stay in place and do nothing, they can stay in place and try to mitigate the issue, or they can leave the affected area. Each of these decisions has serious ramifications for the affected population and for surrounding populations that may provide supplemental food resources in years of particularly poor production or receive migrants if they're leaving the area. Several meta-analyses have attempted to examine the long-term effects of climate change in subsistence-based farming communities in terms of trade, migration, and conflict, but are inherently limited to the historical record. So assessing change over a maximum of about a 50-year time span. While using the historical record provides a lot more detail in individual accounts, it's really limited. The timescale kind of limits us in our ability to reveal the effects of sustained climate change over longer periods of time, multiple generations, especially in these subsistence-based communities that are dealing with traditional ecological knowledge. So climate models that take into account the current production of greenhouse gases and warming trends predict catastrophic increases in global temperature over the next century, which will only continue if left unchecked. At a timescale of only 50 years, our current research into the long-term implications of climate change on historic and contemporary subsistence-based farming communities is still in the trees, and we need to start looking at the forest. Archaeological data sets can provide the necessary longitudinal lens needed to understand population-level impacts of sustained climate change and volatility in these communities. So to address this issue, the project presented here will provide a case study from the Mesa Verde region in the northern U.S. Southwest to explore periods of marginality and migration from 980 to 1280 of the ancestral Pueblo people on the Mesa Verde North Escarpment. So the study provides a 300-year assessment of the impact of climate change on subsistence farming communities and the long-term consequences of extreme climate volatility. And this is done by tracking maize productivity and population movement into and out of the neighboring Montezuma Valley and the Mesa Verde Cuesta. And so this is all done from the perspective of the escarpment, which is my dissertation study area. So the northern U.S. Southwest can be characterized as an arid, high desert environment. Annual rainfall in the Mesa Verde region averages about 39 centimeters per year, which is less than half the average across the United States as a whole. Ancestral Pueblo populations rely heavily on rain-fed maize agriculture, with more than 70% of the annual caloric need of households in the Mesa Verde region coming from maize. So therefore, the populations were highly dependent on annual rainfall to produce enough calories each year to support themselves. While maize is a highly malleable domesticate that can be successfully grown in a range of ecological contexts, and different maize varieties can produce significantly different yields when grown under the same conditions, historic accounts reported that maize crops typically failed in southwestern Colorado when annual rainfall was less than 35 centimeters, so it's a really small margin of error. The Mesa Verde North Escarpment is situated directly between the Cuesta and the Montezuma Valley, directly abutting the northern boundary of Mesa Verde National Park. The escarpment itself is a topographically transitional zone situated directly in the middle of the most densely occupied region in the northern Southwest from 8,600 through about 1,300. So the escarpment provides an ideal case study to look at these issues and trace the effect of climate change and population movement, because the Mesa Verde region as a whole has been intensively surveyed. So we have a really detailed occupation history through time and across this large space. And we also have, because maize was so reliant on having a combination of enough rain and enough growing degree days, are two variables, which we'll talk about in a second. You can really track changes year by year to really have a really fine time scale of population change through the study period. So the other thing that I want to mention is that the Montezuma Valley, North Escarpment, and Mesa Verde Cuesta, which are so kind of in this picture it shows it better. They each have their own advantages when growing maize. So the Cuesta itself is a large south-facing slope, so it gives it a little bit more sunlight throughout the year, increasing those growing degree days. The North Escarpment is a north-facing slope, so it might not be as warm, but in drier years that might help preserve some rainfall. And then the Montezuma Valley itself is typically warmer through time, but they don't receive as much precipitation as the Cuesta typically does. So depending on what the actual climate is doing, each kind of zone might be more advantageous depending on what's going on. Okay, so before jumping into the rest of it, I just want to explain the household data. So I'm using all known households in the Mesa Verde region, and all this data was a product of the Village Ecodynamics Project, a multi-year and multi-institutional project funded by the National Science Foundation. So the DEP basically developed a Bayesian analysis that uses tree ring dates from excavated sites paired with detailed ceramic and architectural data to estimate periods of residential site occupation for surveyed sites with just surface ceramics and architectural features. And that's how we're able to get such a detailed chronological record for these. I think there's probably 4,600 sites being shown up on the screen right now. The power of the Bayesian method is that it allows for the systematic assignment of occupation periods for residential sites across the entire study period or study region using standardized lines of evidence. So, if the dates are wrong, they're wrong for everybody. We can still use those relationships to kind of look at larger scale patterns. So just to explain the model more generally, or I guess two important aspects of the model that I did in this project. One part that you need to understand is a paleo-climate reconstruction, and the other is kind of more of a social reconstruction. And the idea was to try to combine these two variables to understand the effects of climate change within the social landscape. Because people don't just, respond based on the daily weather, they're responding on what's going on in their larger networks, in their larger knowledge base. So the paleoclimate reconstruction was developed by some colleagues of mine, Basinski and Kohler, 2015. Basically what it does is take historic temperature records and tree rings, and historic temperature records for growing degree days, tree rings for precipitation, and is able to extrapolate that information and run a regression model and project it all the way back 2,000 years to basically predict the annual growing degree days and precipitation for every single year from year 1 to 2000, which is wonderful and helpful in doing these types of things. Okay, so that's one thing, and our variables for their growing degree days and precipitation. So every year you need 1,800 growing degree days Fahrenheit and 35 centimeters of precipitation. So then the second kind of social thing going on is this idea that people have kind of different relationships at different distances. Previous research in Mesa Verde region has looked at these kind of catchment zones, all using cross kilometers. And so those catchment zones are at 2, 7, and 18 cross kilometers. The 2 cross kilometers is thought to be the most intensive area, not only for social relationships, but also cultivation. And then that 7-kilometer range is more for, collecting food, non-food resources, but not as intensive. And then you have the 18-kilometer, which is your range for participating in ritual events. And so I kind of use that as the core of looking at what might be happening from the escarpment is kind of using those different zones to see what's happening in each area and how people might be moving through each of those zones based on the changes in climate. So these are the study periods, and this is just to show that basically we have pretty good temporal ranges, and I'm going to use an example from 801130. Okay, so what this shows is basically the sites within the North Escarpment, my study area, and cost kilometer extent going out all the way out to that 18-kilometer range, which is where that red edge is. And then so I chopped that up into a couple blocks. So the clear area in the middle is your 2-kilometer extent. So that's just thought to be like this is part of the escarpment. Then we've got that 2 to 7-kilometer range in the yellow, and then the 7 to 18 cross kilometer range in the red. And then I further split those two zones up into the valley and cuesta. So we have valley 7 and 18, and we have cuesta 7 and 18. So again, trying to capture those different climatic zones that might be going on. So then, those are kind of color-coded dots, not really helpful, but so then I did a 2 cross-kilometer radius around every occupied site, so every contemporaneous occupied site for the areas that were most likely intensively cultivated by each of those households. And then overlaid the paleo-productivity model. So everywhere in green, so again, this is for 801130, everywhere in green likely produced maize, and where that doesn't have it, those crops likely failed. So then I was able to basically harvest and calculate the area of crop productivity, and therefore likely yield, and how much of a population it might have been able to support. So then we get some different fun plots. So this is just a total productive area. These are all color-coded. They're probably difficult to see, but they're all color-coded based on those multiple zones. So that top one, that blue one, that's the Mesa Verde Cuesta in the 7 to 18 kilometer area. And then that red line is the valley at that 7 to 18 kilometer range. So those are certainly the two most important things that are two most interesting things that pop out in this study. And so this is just to show population through time. So again, population is greatest in that cuesta and that valley, the 7 to 18 kilometer range there. And this just show like the percent of supported households, so kind of combining those actual, the known households with the total area of productivity to give you a better sense of how many households are actually being supported. And you can see it generally oscillates in like a 25-year pattern where you have people are doing really well, kind of sucks. People are doing well again, kind of sucks. And then you have a couple significant drops. One of them that we kind of already knew about was this big mega drought in the 1100s, but calculating it here, it doesn't really look like it was affecting many areas except for the Cuesta. So it's got its own interesting thing about it. But pretty much everything is relatively productive until you get into the 1200s, except for the 1100 span in the Cuesta, and then you see another earlier one in the early 1000s. So then I just kind of overlaid the changes in population with that percent, the percent of households supported. And so, I've been staring at this for a long time, and I'm excited to actually dig into it further. But the thing that jumps out the most to me is that when the Cuesta productivity is really poor, you see people leaving the Cuesta, but you don't necessarily see people moving into the valley. The population starts increasing in the escarpment area, that middle area, suggesting that maybe people are starting to move into that valley. They hear that it's like way better out there, and they're starting to leave the Cuesta, but they never actually make it there, and then end up moving back onto the Cuesta anyways. So kind of trying to, think about this in larger terms, wrapping it up more with the idea of climate change in these small communities, is kind of thinking about those three options that we have. We can stay in place and do nothing, we can stay in place and do something, or we can leave. And it seems like people are very resilient. They want to stay in place and they want to do something, but at some point they're going to have to leave. But when they leave, they're not necessarily going to go to some place that's more productive. They're going to be going to some place that just seems like it's going to be better because it's not here. And I think the kind of larger picture that we get, or larger lesson that we can take away from that, is that when we start seeing people leaving their local communities, their local subsistence farming communities, we're going to start seeing increased pressure and increased stress on those surrounding communities, because those are going to be the first ones that are taking in those migrants. And that might be something that we can help support, either helping people move to more productive areas, or providing support in those borderland communities that will hopefully help support people. Thank you.